Today we continue with engineering drawing, and now we will discuss information about bores and threads. So different types of tools are needed for the production of bores, counterbores, and thread. And here we can see the list. Now here are the pictures of the core hole, countersink tap, this hand tap here also, but we won't talk about them this lesson, but we will go for the next slides. So now we will discuss more about threads. So there are types: fastening and movement. Fastening used to where the parts are fastened together, screwed, all kinds of screws, movement threads, feed spindles, drive spindles, so everywhere where it has to be moved or driven. Here this designation we can see in our everyday life. So this denotes metric. It is a nominal diameter, 8 millimeters, and times 40 is 40 millimeters is a thread length. Here's it's also additional designation types, for instance, for thread pitch or fine threads and left-hand thread length. Okay, here we have in German list. Also how the metric thread looks like. Here is an example of 16 degrees with bolt and nut. Also the list. Here also quite similar, according to DIN 13. So here is we have another standard British standard pipe, also called 55 degrees trapezoidal thread, PEG thread. Okay, so we can see here the drawing cut of most spreaded thread types. Here are some designations, but again, this all you can find in the Tabelenbuch Metall at the page 216 and next 20 pages, I guess. So about bolts and nuts, here we have 3 types of screw connection: hexagon head screw, hexagon socket head screw, and screw according to standard DIN 939. Here's a bolt screw. We don't look in details about it, just for understanding, knowledge in general. So here we have also it works. So, and now we have some sketches how bolt and nut looked together in if we magnify it. So we have so-called internal thread, or in German Kern, and also external. Here is designated with an N thread. And in actual view, in sketch, also we designated like a circumference, and the outer circumference is for external. So logically, the internal is here inside, but it takes 3/4 of the external. Here's some representation according to this standard. So taped blunt hole, screw connection. Examples here, examples of dimensioning the threads. So dimensioning which is suitable for production, and this all is can be also found in the book, and we will use it actively in our second task So that's the end of the presentation, and now we will look on the task, and I will
strings, and we have for connecting screws with different standards and nominal metric diameter, as you can see. And we need to sketch these parts connected together with these 4 screws. So similarly as we have done it previous time. So the key element here are the screws. And also, so we have here solution of each screw connected, and here is a view from the top and the full cut. So, and also the table below, it's quite typical. So the main problem here is to annotate these 4 screws, and we can take information from this table book. So you can start with page where is the general information about the screw threads and these nuts. For threads I think we don't need now the detailed information, but for screws we can find here, for instance, the general information for each screw type according to the standards. But if we need to sketch it like here, know exactly that this upper part is 6.4 millimeters, and the upper diameter is 11. But initially we known only the metric diameter is 6. So we need to use this table. And now I will open page 231, and here for the first screw we can take the diameter 6, and third row, because here is written the first row, the standard is used. So that's why we have 11 millimeters for upper part diameter here, and also we have 6.4 millimeters. It's the height of upper part. So this T here, and 6.6. It's this external part, external thread, and 6 is internal. And we can also look, for instance, for the 4th screw. I just need some time to find it. So it should be the F type, and so it should be this one. And we can also take information from the table. So for each screw we have different parameters, so this really depends on this table book. Okay, so we have done it, and see you on the next lecture.